Okay. All right, so let's remember how Kramer's rule works. The first thing we have to do is make our determinant of the coefficients, right? So on our practice quiz, number 1, we have a determinant, or I'm making a determinant out of the x's and y's. Okay? How do I evaluate that? 10 minus negative 21, so I get 31. And I know that that 31 is the denominator of my answer, and my answer is going to be an x and a y, right? Now, how do I find the x? Well, I didn't write my system up there, but you got it. The original system, the equals numbers, the constants over there are 9 and 1. So that 9 and 1 are going to go in place of the x numbers. So I'm going to put 9 and 1 here, and then negative 7 and 5 here. For y, I will do exactly the same thing, only the 9 and 1 are going to go in here for y. So I'll have 2 and 3, and then 9 and 1. So we replace the x and the y, one at a time, with the 9 and 1, the constant numbers in the problem. So what is this one? 45 minus negative 7, 52. And 2 minus 27, negative 25. And that's your answer. Nothing reduces, so that's it. Okay? We'll do one more. Start problem number B, or letter B. Start by writing down the coefficients. So negative 3 and 5, and 2 and negative 8. So what does that equal? Do the math carefully. You'll have a baby calculator for this if you need it. But it's 24 minus 10. I got 14. 24 minus 10. So my answer, whatever it is, it's over 14. Now for x, this time my constants are 2 and negative 1. So 2 and negative 1 are going to go in the x spot. You're just cutting and pasting, so the y's aren't changing. Then when you do y, the 2 and negative 1 go in the y spot, and the x's aren't changing. Please look at that carefully and make sure. You see what I did? Negative 16 minus negative 5. Watch the math. Negative 11. 3 minus 4. Negative 1. So tomorrow, we'll take a quiz. And one of the problems will be just like this, a Kramer's rule problem. All right, got it? All right, get those calculators out. Now we're going to do a calculator problem. Excuse me. All right, so here we go. You need to write down.
Mrs. Ford, do I just have this here?
No, the plate's up here. I had to move the plate. Thank you. Sorry about that. I didn't see it come in. You need need to write down your matrix that you're going to type in, okay? So we're gonna write down the matrix that we're typing in. So I'm doing that right now, lining everything up. When something is missing, we put a 0. So since the bottom row has no Z, I will put in 0. All right, now I get my calculator out. Type it in, type the matrix in. I'm gonna RREF that, and I'm gonna write down what comes out. So what I need to see on your paper is this. This is what I need to see with the new numbers once I get those in.
Oh, bless you.
So second matrix, edit. What are my dimensions? 3 by 4, so 3 enter, 4 enter. Once I get the last one in, the last number in, press enter, then I second quit. Eli, where's the calculator?
The interruption, could you please send Maya and Lilo to student services with their car keys?
Yep.
Thank you.
Alright, once we get that entered, we press second quit. Then we're gonna go back into matrix, and this time pick math. And go all the way down to RREF. Make sure you're going down to RREF. And then second matrix, one more time, enter, enter. And I got this. Is that what you got? So what does that mean? That means my answer is 14, negative 12, negative 6. That's X, Y, Z. So in the problems we did with Kramer's rule, we got X comma Y. Now our calculator is getting X, Y, Z. In problem B, I've got a misprint there. That should be 5y minus 6z. So 5y minus 6z equals 7. That should be a z. So problem B, the bottom equation should be 5y minus 6z. Make sure, if you got a 0, that you're putting it in. In this case, we have no x in our first equation. All right? And let's see if we come up with. Oh, Nanny Burger. All right, anybody got something yet?
Yep. I got this.
All right, let's talk about that. Because this problem, I did not rig. So we need to know how to deal with it when we get crazy answers. I'll tell you right now, it's real easy. It's so easy. All right, so you got this part, looks the same, right? That's good news, that's what we want it to look like. But then did you get like, up here, did you get negative 5.818, da-da-da-da-da? So you have all these crazy decimals. All right, we're not gonna write down the decimals, okay? Here's what we're gonna do. Press your math button, right here, where I'm pointing, the math button. And then press enter twice, and it will change those decimals into fractions. That's your math frac button. So if you press math, frac is the first option, press enter once or twice depending on your calculator, and it will come up with the fraction. So that's what we're going to write down. Negative 64 elevenths, 37 elevenths, and 18 elevenths. So our answer is negative 64 elevenths, 37 elevenths, 18 elevenths. So if we get decimal answers, now, if it's perfectly okay, if it comes up 1.5, that's fine. But if it comes up 1.5876358, on, then use your math frac button, and it will change it into fractions. Okay, so one more time. I type it all in, RREF, up comes an awful looking matrix. How do I handle that? Math, the math button, and then frac, the first option that comes up highlighted. Got it? All right. So tomorrow, or next time we're together, that is what we will do first. Okay. Now let's get our notes. We are ready for problem 3, and it is another one of those big linear programming problems. So, on our notes, problem 3, it's about making suits. So while I'm getting it all set up here, why don't you see if you can start filling in your table. Takes a tailoring firm 2 hours of cutting and 4 hours of sewing to make a knit suit. So knit suit, 2 cutting, 4 sewing. Do those 2 numbers make sense to you? And then a worsted suit, it takes 4 hours of cutting, 2 hours of sewing. At most, 20 hours are available for cutting. So where does the 20 go? Total cutting is 20. And total sewing is 16. The profit on a knit suit is 34. And worsted is 31. How many of each kind of suit would be made to maximize profit? So we are maximizing profit. And then what is the maximum profit? Okay, all right, back there? Okay, so here we go. What's my x and y gonna be? I have to have an x and y. What's it gonna be this time? X will be, what do you think? What am I trying to figure out? Oh, so but that depends on what? How do I make my money? I sell suits, right? So let's let x, right here. Let's let x be the number of knit suits, and y can be the number of worsted suits. So what will this equation say then? What will that say? 2x plus 4y less than or equal to 20? Because I have at most 20 hours. It's going to be less than or equal to 20. What does this row say? 4x plus 2y less than or equal to 16. Now this one doesn't get graphed because this one is my profit, and that's what I'm trying to maximize. So how do I calculate my profit? $34 for every X plus $31 for every Y. Are there any other constraints? Yes. What are my implied ones? They're not in the chart, but they're implied in the problem. What? X and Y are both greater than or equal to 0. X is the number of suits. You can't have negative suits. All right, let's graph it. Here we go. Pink and brown here today. So here we go. There's my pink equation. Remember how we graph it. If we cover up x, let x be 0, then y is 5. And if we cover up y, then x is 10. If we have to extend our axis, we do it. That's just part of the game. If we have to extend it, we extend it. Now, this is a less than, so it'll be shaded down here. Now, what about my brown equation? Well, if I cover up x, y is 8. Maybe it will be brown. It's going to be blue. And if I cover up y, x is 4. And that one is also shaded below. Now, it's actually below the whole blue, but I'm only interested in the part that is pink and blue. So look at your paper. Does it look like it's that right there? Right? All right. Now what? I make a list of all of my black points. So 0, 5, 0, 0, 40, and, uh-oh, that one. So how do I find that? Go back to your equations. 2x plus 4y equals 20, and 4x plus 2y equals 16. That is my blue and pink equation. I want to know where they cross. So what will I do with these two equations, my blue and my pink equation? I will substitute or eliminate or Kramer's rule, something, right? However you want to do it. It looks like if I multiply this one by -2, because I just always eliminate it. Looks like y is 4. And if y is 4, then x is gonna plug in 4 in now. If I plug in 4, it looks like x is gonna have to be 2. Anybody get that?
Which one did you plug for?
Doesn't matter where I plug for it. Plug it anywhere you want, doesn't matter. The answer will be the same. Now what? Now I take all my points and see what the profit is at each point. So if I don't make any nits but 5 worsted, my profit will be 100 and, no, 155. 155. If I don't make anything, my profit will be 0. There's my minimum. If I make 4 knits and no worsted,
136.
136. She's plugging in 4 and 0. Oh, I need help on this.
192.
What is it?
192.
196?
No, 2.
290s?
192.
Oh, 192. So if you're this businessman, what are you gonna tell him to do? He should make, remember we're gonna write a sentence, he should make 2 knit suits and 4 worsted suits for a profit of $192. All right, what do you think? You all right with that? Anything about this you have a question about, because I have to erase it to do the next one. The next one is about skateboards. All right, here we go. Go ahead, get started, see how far you can get.
32,
2.5,
0.5, 40,
40,
1.5,
1.5,
1,
1,
85,
85.
50, and 60. $50.
What was this one?
50
50.
and 60.
Like that? All right, let's see, is he right? Total number for production is 85, beautiful. 40 for finishing, that's perfect. Pro boards require 1.5 production and 2 hours of finishing, good. Specialty are 1 hour production and half hour finishing, that works great. Anybody have a question about those numbers in those spots? All right, can somebody tell me what my constraints are for this problem? What am I going to be graphing? These are, they're called constraints. These are the things I'm going to graph. What will they be for this problem?
2x plus
2x, so you're letting this be x and this be y. So 2x plus
0.5
0.5y
less than
less than or equal to 40. That looks beautiful. And then this one will be
1.5x
1.5x plus y less than or equal to 85.
Then you got the x
And
right
then
here.
we know x and y are both going to be positive. What am I maxing or minning in this problem?
50x plus 65y.
I'm maximizing profit. And as Willow said, that's going to be 50x plus 65y. Now I can tell by the size of these numbers that, remember how yesterday we used a scale of 10 in one of our problems?
Yeah.
We might want to do that again. So then instead of being 1, 2, 3, it's going to be 10, 20, 30, because these are big numbers. All right, so here's my pink equation. So if I cover up x, what will y be?
8.
What are you going to type into your calculator? 40 divided by
0.5.
0.5.
80.
80. So if x is 0, y is 80. So 1, 2, 3, 4, 5, 6, 7, 8. That's 80. And then if y is 0, x is 20. And that one is shaded below. All right, the blue equation. If I cover up x, then y is 85. And if I cover up y, this will be a decimal of some kind, but that's okay.
56.67.
85 divided by 1.5 is
56.67.
56.67. So like here, 56.67, she said. This is interesting. Where's that one shaded? Below. So what's the overlap this time, guys? If I have to be below the pink and below the blue, isn't that just the pink triangle? Isn't this the overlapping part? have 3 points, and I know them all. So I won't have to be doing any substitution, or elimination, because I know all my points. If this line had come out here and crossed, then I would have to do substitution or elimination to find it. But I know all those. So now what do I do? So 080, 080, what is that? 5,200? And of course 0, 0, 0. And what is this one? 1,000? So what are you gonna tell this factory to do? He should make what? 80 specialty boards? For a profit of $5,200. This is another situation where the math is the math, but can you think of a potential drawback to making only one kind of product? That's gonna be most profitable for him, at least initially, but what might happen if you only make one kind, people, not everybody wants that kind, right? And so while this may be the best mathematical model, it might not be the best business model. But this is what you would write down, because this is what the math says, and that's what you would advise them just from a strictly math standpoint. Okay. When I handed out the notes and homework, I also gave you a little practice packet, a couple of sheets with more of these on it. So we're gonna do a couple of these right now because they have a little bit of new stuff in there. So we'll just look at the first one, the one that makes the cars. And does anyone see, go ahead and read the problem. We're just doing the front one. Come on guys, let's focus. Get this done, we'll do your homework problem for you. Let's get this done. All right.
I'm gonna take a picture.
Okay, so here we go. This one is a little different because it has what's called a fixed interval. When you read the problem, let's just start in and start plugging stuff in. We make topaz and mustang. The plant has a maximum production capacity of 1,200 cars. What do I do with the 1,200? Total number is 1,200. That's how many cars I can make. During the spring, a dealer orders up to 600 topaz and 800 mustangs. Now, that's a little different because now we know that there's a maximum on the number of topaz I can buy. So my fixed interval for the topaz, X is gonna be topaz, Y is gonna be Mustang. My fixed interval is X has to be between 0 and 600. So if there's a fixed interval, I will have it labeled in the chart, and then you have to figure out, okay, what is the fixed interval for topaz? What do I know about topaz? Well, cars can't be negative, so I know it's bigger than 0, but it has to be less than 600. Now, what about Mustangs? They're bigger than 0, but less than or equal to 800. And I know that my profit is 500 and 800. Fixed intervals will never, this blank will never be filled in. There's never a total fixed interval. And we're used to seeing that one empty. So I'm not, I shouldn't make that an X, that's just empty, okay? These are empty. If you have a fixed interval, you will always graph it. Okay, there you go. What about that top row? What is that going to look like? X plus Y is less than or equal to 1200. Now, if you put X bigger than 0, Y bigger than 0, I am now marking it wrong, but you don't need to put it because it's right here. We already know X and Y are bigger than 0. So there's no need to put it down this time because you have that interval there. All right, what am I maximizing or minimizing? Profit? And what will my profit be? 500X plus 800Y. I got 3 things to graph this time. Alright, so here we go. I'll do this one in pink. Graph that. That's an X, right? This is my X-axis. Right? I want you to draw a line down through where X is 0. This is where X is 0. And then a line down, oh my. Maybe I should use 100 this time as my scale. So 1, 2, 3, 4, 6. So here's my 0. I just make my line all the way up. When I do my hash mark, I just extend it all the way up. And then where would I shade? Those 2 pink lines, where am I going to shade? In between them. So this equation right here has only an X. Only an X. So I hash marked at 0, hash marked at 600, and extended those hash marks straight up and shaded in between them. No diagonal line, because it doesn't have an X and a Y, it has only an X. Now, what do you think is going to happen with this one? Same thing, only now we're counting on Y. So here's where Y is 0, right here. This is where Y is 0. And then 1, 2, 3, 4, 5, 6, 7, 8. Here's where Y is 800. See how my hash marks are this way? When I get to the one I want, I just extend it. And where is that shaded? Underneath or in between them? So right now, would you agree I have a box? Okay. Now, our third one, and notice that your third one has X's and Y's. So we'll cover up X, and Y is 1200, so 1, 2, 3, 4. And then I'll cover up Y, and X is 1200. And where is that one shaded? Down. So I am inside my box, but below the green line. So I'm going to go ahead and sketch what I think it looks like. What do you think? I think it's this shape right here. It's inside the box. The fixed interval always is going to make a box. So then I threw in that green line and it like cut off the top of the box there. Is that okay? So now I need my points. Alright, so this one is 0, 800. This one is 0, 0. Yep.
It was originally shaded in that triangle, and then you did the green line, so then that becomes it all.
Yeah, because it has to be all three colors. It has to be pink, blue, and green.
Okay,
And this part is a green,
okay,
because I'm below the green line.
right, okay.
So now,
All right, now let's look at this point right here. Pay attention, guys. Remember, on test day, you have to do one of these totally by yourself, and it's worth a lot. It's worth a lot of the test, about a fifth of the test, okay? So you need to make sure you know how to do it. Now, I have no idea what that point is. It's where pink and green come together. This is where pink and green are crossing. Now, it so happens that on this pink line, every X is 600. So I don't know what this point is, but its X is 600. Because it's on the pink line, and the pink line is the 600 line. Well, in my green equation right here, if X is 600, what would Y have to be if X is 600? Also 600. So I'm kind of doing substitution in a way. What about this one? What can you tell me about this one? It is on the 800 line for Y. Y is 800. But it's also on the green line. So if Y is 800 on the green line, then X has to be 400. All right, you have an X and a Y. Start plugging them in. I know this one's going to be 0. Start plugging them in. What do we get for our profit? Our answer is going to be one of those points. 6 and 8's going on there. Did I get those typed in right?
Yeah.
So what are we gonna tell this guy? He should, I don't know, making them, buying them, or what? He should make. What is this? 400, that's the biggest number. So he should make 400 Topaz and 800 Mustangs for a profit of $840,000. Quickly get your homework out. We'll get at least our chart set up maybe. And then we can, I'm talking about the 7-5 homework, which will be due on Monday. We'll try to get it done before then, but get out your homework and see if you can start filling in the charts. I am going to go ahead and hand out the practice test because we are going to start doing this.
It's up there.
Positions, that's awesome. All right, did everybody get a practice test?
What's in my head?
All right, let's look at it.
Can I have a practice?
Jameson needs 4 milligrams of vitamin A. Where does that 4 go? Vitamin A, minimum daily need, right? That's what he has to have. His total minimum daily need is 4. And 125 milligrams of vitamin C. Where does that go? Vitamin C, minimum daily need, 125. Now, where's he getting this from? He's taking vitamins. Brand X has 2 A's and 25 C's. Can you put that in the chart? Brand X, A is 2, C is 25. What about brand Y? 1A and 50 C?
Yeah.
How many pills of each kind should he take to meet the minimum requirements in the most economical way possible? Brand X is 6 cents a pill, so cost for X is 6, cost for Y is 8. Now, this problem is different than every other problem we've done. What does most economical mean? Cheapest. Cheapest. So what do we need to do? We need to minimize the cost. We are going to minimize. Now, that doesn't change anything except when we do all this, instead of looking for the highest number, we're going to look for the lowest number. Now, you might be thinking, well, that's easy, he just won't buy any pills. No, that's not an option. Remember, Jameson needs to take pills to get his requirement, right?
Yeah.
All right, we'll work on that again next time. The homework plate is up here.
Let me borrow it. I'll give it back.
If you need to turn anything in, I moved it up here.
I can take it in this. I guess it's more. Jameson might not get his meds, so they can hold you.
Well, you put the effort
I put 0.6 into the zero.
Every point zero.
Put it in, I don't know. You can always email it to me if you're not here, remember?
Sometimes I just want to.